In this lesson, you will learn about the arithmetic sequence. This is when the difference between the terms is constant. So when it means it's the same, okay? So once we do that, we're going to try and write formulas for the arithmetic sequences. Okay, so looking at the first one, we want to determine if this is arithmetic, okay? So if we look between negative 14 to negative 13, it looks like we're adding 2. Looks like we're adding 2 again and again. Okay, so here, the difference here is constant. Okay, so yes, this will be an arithmetic sequence. And then we need to write the next 3 terms. So if we add 2 again, we would get negative 7, add 2 again, negative 5, and add 2 again, negative 3. Okay, so here are our next 3 terms. Okay, so pause the video for a moment and try the next one. Okay, so we want to determine if this is arithmetic. So between 2 and 4, it looks like we're adding 2. Here we're adding 4. Here we're adding 2 and 2. Okay, so no, this would not be arithmetic because these are not consistent. Here I'm adding 2, then 4, then 2. Okay, so they're different. Okay, so to find a specific term, we're going to use the following equation. Okay, so a to the n, okay? N is our unknown term. So it's unknown. Okay? A to the 1 is the first term. Okay? And again, here we see n, which is our unknown. Minus 1 times d. D is the difference between the terms. And it must be constant. Okay, so if we want to find the 14th term, well, that's n, because we now know what it is. Okay, so n is the 14th term. Okay, if we want to look at the first term, a to the 1, our first term is a 9. Okay, now we need to figure out what d is, which is our difference. So if I look between 9 and 17, I'm adding 8. Here I'm adding 8. And here I'm adding 8. Okay, so there is a common difference, which is positive 8. Okay, so this is an arithmetic sequence. So now all I have to do is fill in the information into my equation. Okay, so a to the n. I want to know what is the 14th term? Okay, so a to the n is equal to a1, which is 9, plus n minus 1. N is 14, minus 1, times d, which is 8. Okay, so this a to the n stands for, well, what actually is the value of the 14th term? Okay, so I can go ahead and subtract here, and I get 13 times 8 plus 9 is equal to a to the n. Okay, so multiplying 13 times 8, I get 104 plus 9 is equal to a to the n. Okay, and then here 9 plus 104 is going to be equal to 113, which is a to the n. Okay, so again, the 14th term here will be 113. Okay, so I'm going to write that in words. The 14th term is 113. Okay, so here now we can write an equation for the nth term. Okay, so if we don't know the term, we can come up with an equation for this. Okay, so I'm going to use the beginning, same, a to the n is equal to a to the 1 plus n minus 1 times d. Okay, so because they're the same terms, I still have d is equal to 8, and I still have my first term, a to the 1 is 9. Okay, so I can fill in that. So I don't know a to the n, my first term is 9, plus, okay, here we have the nth term. We don't know what term it is, so I'm going to leave it as n times the difference, which is 8. Okay, so now I can distribute this 8 to the n and to the 1. So if I bring everything down, a to the n equals 9 plus, here I have 8 times n, 8n, and 8 times negative 1 minus 8. Okay, so now I can combine 9 plus negative 8 to give me 1. So a to the n equals 8n plus 1. Okay, and here is my equation for the nth term. Okay, so I can check myself. If I put in the first term, which would be n. So if I want to know the first term, and then I'll try n being the second term. Okay, so checking for the first term, a to the n equals 8 times 1 for the first term, plus 1. Okay, so that gives me 9. Okay, and the first term is 9. So that means that a to the 1 equals 9. So I'm going to check that off. Okay, so now let's try a to the n. Let's try the second term. Okay, so a to the n equals 16 plus 1, which is 17. So a to the 2 is 17. Okay, so that's the second term, and the second term is 17, so it works. Okay, so right here what I did here and here was just to check my work. Okay, so finally we can graph the first 5 terms of the sequence. Okay, so we see here that a to the n plus 1, this is the equation that we just came up with for the nth term. Okay, so now in the left-hand side we have what is the value of n. So if I fill in the value of n, that means the first term. So the first term is 9. Okay, and I'm going to write that as a coordinate point of the term and the value. Okay, so secondly, I see that the second term, if I fill in the second term, I get 17. Okay, so n, the second term, and the value is 17. Okay, moving on, filling in the third term, I get 25. So the value here, here's the third term, and the value is 25. Okay, the fourth term will be 33. And the fifth term, okay, 8 times 1 is 40, 40 plus 1 is 41. So the fifth term will be 41. Okay, so now I can actually go ahead and graph to see what this equation will look like. So 1, 9. So on the x, I'm going to go 1, and I'm going to go up 9. So 1, 9. The next one is over 2 up to 17. The next one, over 3 up to 25. The fourth term, going over to the fourth on the x and up to 33. And the fifth term is at 41, which is actually a little bit off my graph. Okay, when I connect these, I'm going to get a straight linear line.